Hey, good afternoon, everybody. My name is Scott Friend. I'm a technical trainer here at AWS, and today we're going to be talking about redefining a relationship between drivers, vehicles, and doing that with generative AI. Might not be the first time you've heard that phrase today, but we're going to talk about a practical application of that. So, during our little half-hour talk today, we're going to talk about Iveco Group. We're going to talk a little bit about the background of the company, where their culture is, how they got aligned with AWS in the first place. We'll talk through some of their business problems and what those outcomes are. And we'll kind of talk about how that became a result of working backwards. And then I'm going to hand it over and have Marcel talk about our professional services solution. Marcel was one of the people that helped work with that solution as one of our subject matter experts. So we'll talk about what those details are, a little bit of the technical architecture, how it all worked, and we'll follow that up with some of the next steps for Iveco and how they're going to use this solution to drive other innovation in their organization. So first, I'd like to start with that history. Let's talk about Iveco Group as an organization. Now, they are from Turin, Italy. No, unfortunately, we didn't have anybody from the corporation fly down here to Sydney to join us today, so I'm going to do my best to represent them and what their background was. The organization had been around as Iveco since 1975. It was a spin-off from the Fiat Group. And they were known for building powertrains and large commercial vehicles. Over time, they grew, their portfolios changed. They've got a lot to do with firefighting equipment, other types of services. Well, come 2022, now just 2 years ago, they've spun off and now they're a completely separate organization, the Iveco Group. They've started trading on the stock exchange there in Italy. So, one of the things about that group is, as you see on the title here, History of Entrepreneurs. It is an organization that is really innovative in their approach, in what they do with things. Well, let's talk a little bit more about how they're structured. They've got 8 different brands within their organization. They've got 20 industrial sites, 29 R&D centers across Europe, Latin America, and Asia. They employ over 35,000 employees worldwide. But most interesting point that I found here, nearly 5,500 patents. Very innovative, very much about the intellectual property around what they develop and design. So that's part of their DNA, part of their culture. So let's understand, where does this fit in with generative AI? Where does this fit in with drivers and vehicles? It's a new era for intelligent machines. Vehicle automation. Vehicle automation makes our transportation more sustainable, safer, and more comfortable. You might be wondering, why is that important? Well, there is a huge driver shortage. Iveco makes vehicles. Fleet owners purchase those vehicles. Customers like to get their deliveries, but if there's not enough drivers to make those deliveries, there's a problem. So why are there not enough drivers? Well, it's very hard work to be away from your family for extended periods of time. There's a lot of safety concerns being on the roads. And look, sitting inside the cabin of a vehicle all day, not the most comfortable job. So finding people to do this, not so great. Need to get a solution. This is where Iveco Group started to partner with AWS. Back in 2019, the Iveco Group went over to Seattle, met with a lot of the executives, with the executive briefing center. They did a working backwards session. Now, some of you may have heard of the Amazonian working backwards, and it's really this whole process of understanding who is the customer, what is their outcomes that they need, and how do we actually get the solution that the customer needs the best. So they went through all of this and they got very specific around their customers' contexts and needs. The other thing they really embraced was the Amazon 2 pizza team. Now, I'm assuming the Italian pizzas are a whole lot different than the American pizzas, but they still brought on that 2 pizza team of having autonomous teams, small groups, being able to make quick decisions for themselves. And this let them innovate more rapidly. And the other bullet point here is another interesting one, is pan-Amazon approach. Sure, AWS, cloud computing, tech stack, but it's more than just that. Understanding what's available within the Amazon organization and the Amazon companies, the logistics and everything else that happens, and working through and understanding how Amazon deals with those problems was another part of this whole briefing. As a result of this briefing, Iveco has determined that their cultural DNA was a really close fit with Amazon, and that they wanted to really embrace this partnership. So 2019 started a really aggressive partnership of starting to build innovative solutions. We're going to talk about where they are today with it. And it really started with this problem analysis. What was our problem statement? Who is our customer? Remember that working backwards? Okay, so it's the driver. The customer is the driver. We need to make their lives better. We need to make their journey better. So let's establish those outcomes or those goals. Those drivers need to be able to reach their destinations on time. Why? So they can get home to their families on time, that's why. We need to maximize their safety, so they can get home to their families, right? And of course, we want to minimize energy consumption. Sustainability, massive part of this, but it's also the economy of it. Getting reliable recommendations from trustworthy sources while en route is yet another part of this. So if they had to reroute their navigation, keep in mind, I don't know about you guys, I use GPS navigation when I drive my vehicle, and if they tells me, oh, there's an accident ahead, it reroutes me, that's fine, but I hate to admit it, I tend to have to look off to my screen. Well, part of this is so that they can provide verbal prompts, and the driver's not distracted by something happening over on the dash. All right, so you see that last point again. Arriving back home as soon as possible. It's really about the drivers, their quality of life. So the pain point, as we said, was the shortage of drivers. It's not an attractive job. People don't want to do it. We need to make this something better for them. We need to provide real-time information to what's happening in their route while they're traveling. And we also need to be able to provide training, because the more technology they have to deal with, the more they need to learn how to work with. And part of this is also electric vehicles. Okay, so the solution that comes to be Driver Pal 3.0. If you're wondering, yes, there was a 1.0, there is a 2.0, but 3.0 embraces generative AI. As generative AI has been emerging in the last 6 months or so, yeah, this is a rapid project here we're talking about, it was really becoming more and more important to bring generative AI into a more robust solution on an already evolving platform called Driver Pal. This involved basically 3 areas. Proactive, ahead of time, vocal prompts, right? Not those things showing up on the dash, but vocal prompts, so the driver does not need to be distracted and take their eyes off the road. So real-time notification through voice and visual notifications. Collaborative assistance, enhancing that driver experience. This means we would need to have that verbal feedback, we need to be able to collaborate, we need to be able to go back to our logistics centers, and multi-language support, right? Drivers are going to speak different languages all around the world, especially around the European areas. We need to be able to have multilingual support. What better way to do this than generative AI? So, that brings us to the Driver Pal 3.0 solution. To talk more about the outcomes of the solution, and to talk about how that solution is built, what I'm going to do is I'm going to hand this over to Marcel, and he's going to take us to that next step. Okay, Marcel.
Thank you, Scott. Are you ready to dive a bit deeper, dive under the hood, as we say? So, as you heard, Driver Pal 3.0 used generative AI. To be fully precise, it used something called a large language model. You certainly have heard this term, LLM. So what is generative AI? So generative AI is a subset of deep learning which deals with creating content. So it can be conversation and text, that's the most common one, stories, images, now video and even music. So the idea here is really creating something new instead of extracting information from an existing medium, which is what deep learning is all about until generative AI. So those large models are large and trained on a large corpus of data. We are talking sometimes the entire internet. And what come out of this training is something called a foundation model, right? A model that can generate one of the modality I mentioned: conversation, text, image, video, and music. So at the core of generative AI is those foundation model. So they are trained with a vast amount of unstructured data. If you think about a large language model, as I said, it's almost the entire internet. All you tweet, all Wikipedia, books, basically everything you ever wrote on internet, you can assume that it has been used to train a model, right? It contains a large number of parameters, so that's where the large comes through. So what does it mean, large number of parameters? In the case of large language model, we are talking about 10 billion, even 100 billions of parameters. And just to give you an idea, one parameter is it's a number, it's a float, so 100 billion of them. So that's why they are so-called large. Right? So far, deep learning was dealing mostly around few 100 million parameters, so we have one order of magnitude beyond. So this helped those models to learn about language, to learn about drawing image, to learn about voice, and that helped us to use them for a wide variety of context. But most importantly, you can also customize those foundation model with your data to be domain specific. And this is done via something called fine-tuning. So to give you an example, foundation model in large language model, the only thing they do, they put words after one another, the most likely word, right? That's the only thing they can do, right? So it's quite nice to complete the sentences, but it's not great just to answer a question, because there is can be many answers, many ways to answer. So that's why we fine-tune those models, and then those foundation model become something, a chat model, on something called an instruction model that follow instruction. So that's where we jump to those domain-specific foundation model. And that's where come in Amazon Bedrock. So those models, as I said, are large, very large. To run them efficiently or to train them efficiently, you need GPUs, right? Those graphical units that are in your gaming computer, for example. But you don't need only one GPU, you need several GPU, maybe 10, 20, sometimes even 50 GPUs, right? To just be able to train them and to use them at speed and efficiently. So as you can imagine, if you already try to deploy model on multiple GPU, it's not straightforward, it's not that easy. Moreover, there is a lot of different models out there, a lot of foundation model, a lot of pre-trained model. Do you want to use a chat model, or do you want to use a model that has been trained to answer instruction? You want to try different things. So you don't want to go again through the whole process of redeploying those monsters on your infrastructure. So Amazon Bedrock allows you to easily experiment with different models, right? It also allows you to add element to the model that makes them more tuned to your application. You can fine-tune foundation model, or you can fine-tune model that are already chat model or instruct model, or you can add something called a RAG, retrieval augmented generation. This is, we call it also knowledge base. This is just a way to tell the model, hey, you have a question, you can read documentation and then provide an answer. You don't have to know everything. And that's a very efficient way to transfer knowledge to a model. And Amazon Bedrock has a lot of different models. So on the screen, you can see a few models we propose. There is already more of them. You can see, for example, if you want cutting edge text generation, you can use Claude 3 from Anthropic that has been released I think a few weeks ago. We also have the famous model Llama 2 from Meta, so you can very quickly work with this model. We also propose a whole range of models under Amazon Titan, from text generation, image generation. And we also have other models that have a bit of more obscure role, that you don't use directly, but are used really in the fine-tuning of this model or adding those knowledge base to the model. I'm thinking about embedding model. So for example, Cohere proposed a very powerful embedding model. We also have excellent embedding model in text and video and image. So that is Amazon Bedrock. Allows you to jump quickly and to use generative AI. So all what I say, there is plenty of model out there. There is plenty of library that allows you to build those retrieval augmented generation model. What's really matter, what makes the difference is the knowledge you bring to the model, right? I mean, asking a model why the sky is blue, that's okay, that's nice, right? But quickly you want your model to be able to read your data, to read your information, to read your document, to access your database. So that's where it's really important, and that should be really the core of the message. Gen AI is nice, but it's much better with your data, right? And that's exactly how we help Iveco Group to differentiate with their domain knowledge. And we did that with a data lake, again, something you heard often, but we added a mobility spin. So what does it mean? Well, in that case, it means the source of the data comes from a truck that is on the road. It doesn't come from a database, it doesn't come from something fixed. So all this mobility data lake, what it is really is collecting the data generated by the truck or the data collected by sensor on the truck and to bring them to the cloud. And this mobility data lake has mostly two types of components. The first type is really collecting, storing, and querying. So in terms of collection, those data, we have Amazon Kinesis that allows us to ingest a large amount of data from outside and store them in the cloud. We have also Amazon Redshift, our data warehouse solution, to store a large amount of data in a structured fashion. But then with those data, you want to change them, transform them. ETL job, this is the job of AWS Glue. And then we have all the processing of the data, right? So you can imagine about Amazon QuickSight to visualize those data, or Lake Formation to store all the metadata, all the access of this data lake. So that's what we build over the course of several years with Iveco, is this mobility data lake, which is used and connected to the truck that run in the street. And once with those data, you can start to do the really powerful thing, generative AI, machine learning. But again, without this, don't bother, right? Data is key to do good generative AI. So let's dive into the architecture of Driver Path 3.0. So it's mostly composed in 3 layers. So on the left, you have the API layer, fairly self-explanatory. Then on the right, we have the data layer. As I said, data is key. And on the middle, we have the generative AI layer. Think of the brain that connects everything together. So let's go through this API layer. The driver in his truck asks a question. So the driver is not going to type the question for obvious security reason, but he got to speak the question, right? So the voice is translated into text, and then it goes through the process. So very first, we have Amazon Route 53, which is our DNS service to put the service to allow access for a wide range of locations to the service. Then we have AWS WAF, a security layer that scans the traffic and try to identify and cut the malicious traffic. And then finally, we have Amazon API Gateway, our service that allows you to build API and to serve those API. And that's really where the query from the user are routed to the right tool, right? And of course, there is a level of authentication, driver authentication, which is run by Amazon Cognito. Then I jump directly to the right-hand side, the data part. So, as I said, we have all those data, right, in a data lake. But generative AI, those large language model, we think they are smart, but you still need to transform a bit those data, right? So that's why you can see in the middle AWS Glue ETL job that will transform the data and prepare those data to be ingested by our generative AI model. So it can transform some structured data and put them in Amazon Redshift, or we have also semi-structured data in DynamoDB, which is a NoSQL service. Also, very importantly, we have connected all the algorithm that Iveco has developed through the year. It can be statistical algorithm, deep learning algorithm. A good example is the truck will record how much you use the brake, what is the pressure of the brake, how many seconds you use the brake. And this is raw data, right? You cannot do much with just that, but then you can add on top of it a model that will compute when your brake pad will need to be replaced, right? Predictive maintenance. And this is done with machine learning and statistics. That's an example of process data that you put in Redshift. And we also have Amazon S3, right, to store everything which is unstructured data, text. Think the driver manual, vehicle manuals, also all the information internal to Iveco. And all of this is used to help the brain, the generative AI model, the large language model, to provide a meaningful answer. So how does it work? So you can see on the upper left, there is something called the multimodal agent, right? So what is this doing? So this receives the query from your driver and go back and forth between the model and the different agent he had access. For example, the model read the query from the driver and ask the agent, hey, I need some unstructured data. Then the agent go to query S3 via Amazon Kendra, which is our search and indexing engine. So it will query the index to get a good reference that should help to answer the question. It will also handle something very important in chat is the memory, right? When you have a conversation with someone, you don't always need to repeat what has been spoken 1 minute ago, right? You have this memory of the conversation. And even if you meet someone again after a few days, this person will know what you talked about, memory of the conversation. So that's the branch going down from the agent where we store all those information. And for the few of you who are aware of, we can see Amazon Comprehend. What is it doing here? Well, Iveco has some good practice in terms of security and how they store personal information of their driver. So here we have a layer where we remove all the personal identification from the conversation before storing them. So then the whole architecture is compliant with Iveco privacy management and also with the rule in Europe. Have you certainly heard of the GDPR? So, as I said, what we have is a RAG, right? This retrieval augmented generation. So you ask a question, what is the echo switch and how can it help me? After a few seconds, you will get an answer from the model. The answer will be voiced to you in the truck because, again, you don't want to read a screen while you drive. And this answer talk about what it is in general and how can it apply to you. Right? So if you look at the RAG, this agent will receive the question, right? The agent will then communicate to the model, hey model, this is my question, how can I answer to that? And the model will direct the agent, for example, to the structured data, right? For example, in the answer you can see it's related to enabling or turning off this echo switch 15% of the time. This comes likely from a database, so the model has instructed the agent to execute a SQL query to the structured data and come back with the answer, right? And then the agent will provide this answer to the model where it can start to formulate a natural language answer, an answer you will hear from someone. Yeah? Then maybe this model needs some unstructured data, right? Then the agent will query Kendra and the unstructured data, let's say from the driver manual, explaining what is this echo switch. And again, so you have this sort of dance going back and forth between the model asking what it needs and the agent connecting to different elements of this RAG. And nowadays, you can even add a visual type of RAG, right? You can ask on image or you can query images. So the field is moving extremely fast, adding new modality. And of course, something which is really important and what Bedrock's bring you is, I mentioned customer data, right? And in everything I talk, all the customer data are secure and they stay within customer control, within Iveco's account, right? For example, none of the customer data are ever used to train in the future those large language models, right? Also, all the data are completely encrypted. Amazon Bedrock and the underlying model can handle those. So encrypted at rest and encrypted on transit. And obviously, especially if you want to fine-tune your model, the fine-tuned model, it's your model, right? It has been fine-tuned with your data, it stays with you. We don't use this information to fine-tune our own model.
How is my driving style?
Based on the provided context, your driving style seems mostly appropriate, with a few areas that could use some improvement. Specifically, cruise control usage could be improved by exploiting it more often whenever possible. The accelerator pedal usage needs work. Try to reduce harsh acceleration occurrences and press the pedal more gradually. Usage of the eco switch and eco roll features should be improved by keeping them enabled at all times during driving. Overall, focusing more on using cruise control, driving more gently and enabling eco features should help you optimizing your driving style. Hello Kevin, let me give you some information about your daily trip. Your vehicle's health is good. The weather along your route will be perfect with 24 degrees Celsius and clear skies. Nowadays, your fidelity program level is expert. How can I support you today?
Can you tell me how to improve my level?
Sure, you can work on many different aspects to improve your level, from reducing the number of harsh braking to increasing the usage of predictive cruise control. I can provide you all the details if you want. As an example, keeping the eco roll active during your daily missions will grant you the master level in about 2 weeks.
Great, let's do so.
Due to a car accident in 70 kilometers, the delivery plan has been updated. Your new destination is Milan MPX2. New estimated time of arrival is 2:30 p.m. 1 hour 15 form now. Delivery warehouse is already informed and waiting for you. Have a safe trip.
Okay, let's navigate to the new destination. Thanks for optimizing my time.
My pleasure, Brenda.
So that was a demonstration what is DriverPal 3.0 and what it can do and how it can be used. So this journey we started with Iveco on DriverPal 3.0 will obviously scale across Iveco in different area, either customer facing or internal. So for example, engineering and design, finding information about what has been built and some design. You can think manufacturing, sales and marketing. So generative AI is a new technology that can be applied in a lot of area to augment and to improve the interaction with all those tools that are already existing or new tools. And with that, I will conclude our talk. So you can redeem the 3-day trial on Amazon Skill Builder. And thank you very much for your attendance.